Hello, online learners, and let's look at the sense of hearing. Now, hearing is very complicated. I find it absolutely fascinating. I want you to get an idea of the general how does it work without going into too much detail as to what the organs are and too much detail. The general gist of how the sound vibrations get from the outer ear to the brain will make me happy. What I want you to realize is the ear is actually responsible for two things. It's responsible for hearing, and it's also responsible for the maintaining our equilibrium or our balance. When we hear, we take sound is vibrations in the air. So they will come and they will be collected from the lovely outer ear, and then they go through. There we go. So the outer ear goes from the outer part to the tympanic membrane or the eardrum. So you have your auricle and you have your external auditory canal or your external auditory meatus. So it collects the sound and puts it in and puts it towards the tympanic membrane. The tympanic membrane is the divider between the outer ear and the middle ear. The middle ear is the location of the ossicles, or the little ear bones. So there's the malleus, the incus, and the stapes. They spell miss, if that helps you to keep them in order. And also, because of the angle of these bones, this will transmit the signal, but it also magnifies it about 20 times. Now, another special feature of the middle ear is this auditory tube, and it goes to your throat. And the auditory tube is what will help you balance the pressure. I don't know if you've ever gone up the mountains or gone in a plane and you get so your ears are in pain and then suddenly they pop. I have to chew gum so that I don't get this pain. And in the process of chewing gum, you are getting air into your mouth, which will help equalize this internal chamber with the outer air pressure. That's called the eustachian tube. Okay, the sound pressure comes in, the pressure waves cause the tympanic membrane to vibrate. That causes the ears to vibrate, which will then cause vibrations on the oval window, and that will then be part of the inner ear. The inner ear has two parts to it. It's got these loopy things, these semicircular canals, which are used for equilibrium, and balance, and there's also a little bit here called the vestibule, but not mentioned in this class. Then you have this snail-like thing here called the cochlea. And the cochlea is where the sound waves are interpreted to nervous impulses. So we'll come back to that in a second. So let's make sure I got all the bits. The ear is responsible for hearing and for maintaining equilibrium. When we hear vibrations, usually via the air, they are transferred into audible sound by the 8th cranial nerve, if you remember that from a couple chapters back. So the external ear is the outer protection. This is the part we see. It's called the pinna or the auricle, and it includes the canal leading to the tympanic membrane. The tympanic membrane or the eardrum has 3 small bones, and the eardrum will cause these bones to vibrate, called ossicles, and they will amplify the sound, and once it's amplified, it'll be transmitted to the oval window, and the oval window will then transmit the sound waves to the inner ear, and the inner ear is divided into 3 parts. Just worry about the labyrinth. And there's 3 parts to the inner ear. There's the cochlea, which is sound, the vestibular chamber, which deals with balance, and the semicircular canals, which deal with rotational balance. So here is what the inner ear looks like. Here's the cochlea down here. So the oval window will cause the fluid in this area to vibrate. And it will go, and it starts out thicker and it goes thinner and thinner, or the other way around, I don't remember. And on it are hair cells. And these hair cells, when the membrane gets to a certain thickness, the vibrations of the sound will cause the hair cells to move. And as the hair cells vibrate, they will then send the nervous impulse to the brain, which will go to the temporal lobe, if you remember. Okay? So it's very detailed. The organ of Corti is quite fascinating, but I want you to realize the cochlea is curled. It's got this fluid in it called perilymph and endolymph. And then there is this membrane that vibrates. When the membrane vibrates at certain frequencies, it will move the hair cells, and that will send the message in. This is a semicircular canals. Notice the semicircular canals, one goes in each plane, so that way you can go if you're doing this, this, or this. This, or anyway. No matter what way you rotate. And when it comes to balance, there is fluid in here too. When you are rotating, your fluid will start to rotate, and it will cause little organs in there to bend with the fluid rotation, and that will send the nervous impulses in. Okay? Great. A lot more detail in actually how this works, but that's the general gist. So let's look at cochlea is a bony spiral connected to the oval window. It contains a fluid which helps transmit the sound. The sound is then transmitted to another section which contains another fluid. The sound is then carried to tiny like receptors that are stimulated and will conduct the signal to the brain via the vestibulocochlear nerve, or number 8. And where I remember that is your ears kind of look like an 8. Kind of, not really, but kind of. Okay? So to summarize, sound waves will enter the external canal, vibrate the eardrum, vibrate bones, vibrate fluid, cause the hair cells to move, creating a nervous impulse. That's summary enough. Okay, there we go. Lots of vibration. Now, the inner part of the ear is also needed for equilibrium. The semicircular canals process sensory input related to equilibrium, and the nerve endings in a form of hair cells. And these hair cells will vibrate, putting stimuli to the brain. Okay? Fluid will move. The reason you can get dizzy is that when you spin around, your fluid is still moving, and when you stop, it takes a little bit for your fluid to still move. The reason why you can get motion sickness is sometimes your eyes and the receptors in your brain aren't matching up, and that confuses the brain. Okay. Good. Taste. Taste is called the gustatory sense. There are papillae or bumps on your tongue, and the tongue is then, let me show you a picture of the tongue. There's all these bumps in your tongue, and in between each bump there are these little valleys, and in the valleys are these taste buds. Now, the taste buds detect 5 different senses. It's 5 different tastes, sorry. Sweet, sour, salty, bitter, and umami. Umami is not the traditional 4. It's the new one that came up because of all these food additives that contain glutamate. Glutamates can be detected and create this umami, and it's not a combination of the other 4. Okay. Your body changes, refined taste. Your taste can be refined. I don't know if you've ever, I took coffee tasting lessons, and that helped me pick up different flavors, and it actually helped me with my wine and beer tasting, but still, most things are too spicy for me. So there is theory on the tongue that the tip is the tip is for sweet, the sides are for salty, the back is for bitter. Okay. Smell. Smell occurs because there are these receptors in the back of our nasal cavity, and you may realize that if you have a cold, that smell receptors are actually influence our taste too. So if you have a cold, nothing tastes exciting. Okay. So the sense of smell arises from receptors located in the olfactory region of the upper nasal cavity. Taste and smell are closely related, and smell is linked to memory. If you ever have like the smell of pie reminds me of home, or the smell of gingerbread reminds you of Christmas. Okay? Good. Touch. You have touch receptors in your skin, and there's a bunch of them according to this textbook. Mainly there is touch. Used to be touch, heat, pressure, and cold. Tickle and I guess pain, slightly different. Your skin has certain receptors that will send these information to your brain. Now realize the touch receptor is different than the pressure receptor, which is different than the heat receptor and different than the cold receptor. And even hot and cold receptors are relative. You may not notice that if you're outside in a cold, in a hot day, and then you go into a cold pool, as opposed to if it cooled down later and it's not as cold out. If it's cold outside, the same pool may seem warmer. Anyway, it's receptive. So, touch. Touch receptors are small round bodies called tactile corpuscles, and there's sensor receptors too. Touch can be adaptive. You may notice it when you put on your shirt. You can feel your shirt, but as the day goes by, you don't feel your shirt. Pain. Pain is very important because it's a protective sense. If we are causing pain, usually we stop doing something. And there is different types of pain, and it's distributed throughout the body with the exception of, I think, the brain and the liver. Yeah, something like that. Pain receptors do not adapt, and they will feel pain as long as the stimulus is there. Now, there's something called referred pain, which is sort of the internal pain. External pain, you feel it and you can locate it pretty well. Internal pain is referred pain, and it comes from your internal organs. And often that pain goes somewhere else on the body. And a good example of that is during a heart attack, you can have pain up your arm because the pain in the heart is referred over the body, which often makes it difficult to identify what's causing the pain. Then you have phantom limb pain, which is a special kind of pain that they can't understand. Usually after an amputation, a person will still feel pain even though there's no limb there. And it has to relate to the fact that there's a certain part in your brain that's been receiving these receptors for a while, and now the brain is still working even though information isn't coming out. Very interesting. There's a type of receptors, referred pain. So few eye disorders. Conjunctivitis, which is basically pink eye. You have an inflammation on the outside. Ew, nasty pictures. D is conjunctivitis. Or actually A is conjunctivitis. B is a cataract, which is the clouding of the lens. C is just nasty. Okay, a cataract is the clouding of the lens. Glaucoma is internally. Then we talked a little bit with sight about how you can be farsighted, and that's a result by the focus of the rays are not on the retina, they're behind the retina. So you're farsighted. You can also be nearsighted if no, it's the other way around. Farsighted, yeah, farsighted, the lenses focus after the retina. Nearsighted, the lenses focus before, usually because they have a long eyeball, and I have a long eyeball, so therefore I'm nearsighted. I've now become presbyopic too, hence the fancy computer glasses. Presby is the word for old, so presbyopia is a result of needing reading glasses because the contractivity of your lens it loses it with age. Otis medius is an inner ear infection. Tinnitus is the ringing in your ears caused by taking too much aspirin, also caused by being in really loud places. And that's about it for this chapter. Enjoy your senses. I hope it made sense. Hee hee hee.